Welcome to Lesson 6. This is where Fail2ban stops being a single tripwire and starts behaving like a real defense system. Production servers don't run one jail. They run 5, 10, sometimes 20. SSH, Apache, postfix, Recidive, custom app logs, and every one of them is reaching into the same iptables firewall. Over the next 12 slides, we'll look at how that shared chain actually lays out, why jail order matters, what happens when two jails catch the same IP, and the performance cost of stacking them. By the end, you'll have a ship-ready 5-jail preset and the diagnostic skills to keep it healthy. So here's the architecture lesson that everything else in this course rests on. Jails don't have private firewalls. They all write into the same kernel iptables input chain, but each one carves out its own subchain, prefixed f2b-jail name. When a packet hits port 22 from some IP, input walks those F2B chains top to bottom: SHD, apache-auth, postfix-sasl, vsftpd, Recidive, and the first chain that matches and rejects wins. No match anywhere? It falls through to accept. And the order you see here isn't alphabetical. It's the order the jails started. Remember that. We'll come back to it. Now that you know the structure, here are the 3 commands that let you actually see it. The first one, iptables, L-input, grept for F2B, gives you a roster of every active jail at the firewall level. The second drills into one chain, like F2B SSHD, and shows you the actual banned IPs sitting there as reject rules. And the third is a Fail2ban client one-liner that aggregates ban counts across every jail at once. 2 seconds to run, and you'll answer 90% of "is this thing actually working" questions without guessing. Here's where order quietly becomes a performance feature. Iptables walks the input chain top to bottom, and the first F2B chain that rejects a packet ends the trip. Nothing below it ever runs. So if Recidive sits last, every packet from a known repeat offender still gets checked against SSHD, Apache, and postfix first. 3 wasted lookups per packet, multiplied by hundreds of packets a second. Put Recidive first, and your worst offenders get dropped on lookup 1. The per-service jails only ever see traffic that isn't already banned. Now consider a different overlap. Not jails sharing a firewall, but jails sharing a log file. Apache writes one access.log, and it's perfectly valid to point 2 jails at it. Apache-auth, watching for WP login brute force, apache-badbots watching for 4xx scanners. Each jail opens its own file handle, keeps its own counter table, and gets its own F2B chain, so the same IP can sit at 4 of 5 in one jail and 1 of 2 in the other, completely independently. The one trap. If your 2 filters rejects overlap, a single log line gets counted twice. Run Fail2ban rejects against your filters and confirm their disjoint before you ship this. Here's the attack pattern that keeps senior engineers up at night. One IP, 198.51.100.7, hits SSH twice, Apache once, postfix twice, 5 hostile actions across one day, and not a single jail trips its max retry. Each counter sits politely below threshold, so the firewall stays empty. This is the bouncing IP, and it's exactly the gap Recidive was built to close. A meta jail that watches Fail2ban's own log, sees 5 found events across any jails, and drops the hammer for a week. Now, before you go stacking jails like Lego bricks, understand what each one actually costs. Fail2ban is a single Python process, but every jail spins up its own filter thread, its own log handle, its own counter table. Roughly 5 megabytes of RAM per jail on top of a 25 meg baseline. CPU stays near 0 when things are quiet, but climbs 1 to 3% per jail under active attack, and a bad rejects with catastrophic backtracking will pin a core, which is why you run Fail2ban rejects before deploy every time. Disk grows with the persistence database. Cap it with DB purgage, and startup time scales linearly. 50 jails means 30 to 60 seconds, where system thinks you're up, but your jails aren't actually ready yet. So when one of those jails starts misbehaving, flooding you with false positives after a service upgrade, or chewing memory, you don't rip it out. You have 4 moves in escalating order. Fail2ban client stop sshd kills it in memory right now, reversible on next reload. That's your panic button. For something stickier, set enabled equals false in jail. Local and reload. The daemon forgets the section, the F2B sshd chain disappears, but your config stays readable. Use status first to diagnose without touching anything. And deleting the section entirely? Almost never the right answer. Fix the filter instead. Now, let's put it all together into something you can actually deploy. 5 jails on 1 small box. SSHD tightened to 3 retries, apache-auth for WP login hammering, apache-badbots catching the 4AX scanner noise, postfix-sasl for mail brute force, and Recidive at the bottom as a meta jail. That bottom placement matters. Recidive registers last but bans first, watching the other 4 and dropping a 1-week blanket ban on anyone who racks up 5 bans in a day. Notice the default block. Ignoreip protects your own networks, and bantime.increment doubles the punishment for repeat offenders up to 7 days. After reload, Fail2ban client status should list all 5. And with that, Stage 02 is in the books. You can now write a jail.local from scratch, tune the 3 numbers per attacker profile, layer Recidive on top, run 5 jails side by side without stepping on each other, and read the F2B chains in iptables to see exactly who's banned and why. Stage 03 is where we drop down a level into the filters that decide what counts as an attack in the first place, starting with rejects and host anchors, then writing your own filters from raw log lines, and finally a proper look at actions across iptables, neftables, and ipset. Quick recap of the 6 skills you walked away with from this lesson. You can read the F2B chain architecture and know that input walks each jail chain in start order, with the first reject winning. You can inspect chains and ban counts from the command line, push Recidive to the front so it short-circuits under attack, run 2 jails on 1 log path without overlap, reason about RAM and SQLite growth per jail, and disable a jail cleanly, hot or persistent. That's the 2-minute answer to, is this config any good? And with that, Stage 02 is in the books. You've got the shared chain model, jail ordering and overlap, a realistic performance budget, and a 5 jail preset you can actually ship. Stage 03 picks up in Lesson 07, where we go inside the filters themselves, the host placeholder, anchors, and character classes, and how to write rejects that won't catastrophically backtrack on you in production. See you there.